everyone. I am super excited to see all of you here today. It's so wonderful to see so many both familiar faces and new faces. For those of you who have been here for many years, as I know some of you have, you've probably heard me up on stages like this one say every year, this is my favorite week of the year. And it's really true, and it's because we get a chance to hear from all of you about all the amazing work that you've been doing using the tools that we build. You know, we're engineers, we don't spend a lot of time out in the field the way you do, having a direct impact on the world the way you do, but when we hear about it from you, it helps energize us, helps us understand what we need to go focus on for the next year. So really thrilled to have you all here with us. Very much looking forward to hearing from all of you, but first, you'll be hearing from us. So over the next about an hour, you'll be hearing about the latest news, product updates in 3 major areas. So in a little bit, you'll be hearing about Earth Engine. I know many of you have been Earth Engine users for a while. This is our cloud computing platform for geospatial data analysis at scale. And today, you're going to be hearing about some of the new capabilities that we've been building to supercharge research. I'm especially excited about things that we're bringing that are powered by machine learning and AI in new ways, and they'll let you tap in to some of those capabilities in your own research, as well as some very exciting work we've been doing to help you integrate Earth Engine into your research workflows more easily, more seamlessly, bring more power there. But also you'll be hearing about some of the work we've been doing to help you bring the power of Earth Engine to operational use cases. I know a growing fraction of this audience over recent years has been on the operational side, coming from the public sector, from the private sector, really working on using the science to drive impact in the real world. And we know that running a production system is different than running a research system. And so we're trying to help bring you better and better tools to bring the science to bear on those sorts of problems as well. So you'll hear all about that. After that, you're going to hear about an exciting new whole category that didn't even exist before, that Rebecca alluded to just now, which is our environment APIs in the Google Maps platform. So these are APIs that bring specific insights to especially operational developers in areas like solar potential or air quality that you can integrate into your products, your applications, to help people around the world make better decisions in this changing environment. And then, before you hear about those things, you'll be hearing about Google Earth. Earth is, of course, what brought Google to this whole space in the first place over 15 years ago. It was the first chance that many people around the world had to really see the Earth as a unified whole, to fly anywhere on the planet, to see change that was happening around the world. And that's what got us originally excited about the power of computing to help in this space, and started this whole ball rolling. It may look from the outside like we haven't been doing as much in the world of Google Earth recently, but in fact, I'm excited to say that we've been doing a ton of work behind the scenes, and you're going to start to see the fruits of that coming right now. So we've been busily producing a whole new update to the app across 3 platforms. You're going to hear about that today, and you're going to hear about some early examples of very new capabilities that we're bringing into the Google Earth platform to help you solve bigger and bigger problems at global scale around the world. Whether you are a scientist, a developer, or a decision maker who just wants an easy-to-use interface to make better sustainability solutions, or decisions rather, there's a whole suite of products that you'll be hearing about. One thing I want to highlight, for those of you who've also been here for several years, is you'll see that we've been expanding the product family and expanding the team and family that are building these kinds of products here at Google. I've been incredibly excited to see Google continuing to grow our investments in sustainability in a range of areas, including through these products. So keep an eye out for a bunch of very new and exciting things. And without further ado, I'm going to hand it to Patrick and Chi to start with the latest news on Google Earth.
Patrick, I'm product manager on the Google Earth team.
Hi, and I'm Chi Pham. I'm a user experience designer on the Google Earth team.
And we're going to talk to you a little bit about what's new in Google Earth. And as many of you in this room knows, geospatial data and insights are uniquely powerful tools for understanding and addressing humanitarian and environmental issues, helping with things like crisis response, to cultural preservation, to environmental sustainability, and much, much more. And Hurricane Katrina in 2005 was really our first ever geo crisis initiative with Google Earth And since then, the product has continued to be helpful for things like crisis response, preservation, and sustainability efforts worldwide. And as we adapt to a world grappling with the growing challenges of climate change, accessible tools like Google Earth with global satellite imagery catalogs are becoming vital resources to help understand and mitigate environmental impacts. And Google Earth is really a no-code data visualization, creation, and collaboration platform that lets you browse over 36 million square miles of satellite images, covering more than 98% of the global population. And paired with easy-to-use no-code tools and collaborative and interoperable data formats, it's really easy for anybody to pick up and use. And we are seeing Earth users having a big impact in the natural and built environment, doing things like monitoring areas to detect and analyze climate change. So for instance, Earth's time-lapse feature lets you observe cloud-free change of the planet's surface for the past 38 years, made with over 15 million satellite images from the Landsat program and the European Sentinel program. Earth is also a commonly used tool in the development of utility-scale clean energy projects, used throughout the development for things like prospecting land, through procurement, all the way through construction. We're also seeing Earth users working in conservation projects, restoring and protecting land, wetlands, and oceans, as well as being a useful tool for architects and urban planners to orient and observe on the built and natural environment to help build smarter and more sustainable cities. And building on the rich foundation of Earth Pro that launched all the way back in 2005, and the more recent version that launched in 2017 on mobile and web, we're now taking additional steps to cloud-enable Earth's capabilities and make it easier to work and collaborate on Google Earth. And with that, I'm going to hand it over to Chi to talk about some of the recent updates.
Thank you. Great. All right, so I am super excited to say that just in time for G4G, we have launched a new version of Earth across all the platforms, web, iOS, and Android. I just want to take a quick moment here to thank everyone who was a trusted tester with this new version. We really couldn't have done it without your incredible feedback, and we really, really appreciate your help. So a round of applause for you all who gave us feedback. Thank you. All right, so what's the fuss with this new update? In short, the most recent update includes a new architecture, a new interface, and a new tech stack. What does that mean? It essentially means we did an extreme home remodeling makeover. We got a new blueprint, we changed the floor plan, we took down some walls, we put up some walls, we painted those walls, we had to rearrange the furniture, and we had to take out some furniture. But all of that to say, this massive home remodel was done in order to optimize for productivity. The new version is built to be able to scale to support a more advanced user journey and capabilities. And so key tasks are just faster to perform now in the new version than they were previously in the old version. We're also excited to say that we're enabling cross-platform workflows. So you can start a project on web and finish it on your mobile device, or vice versa. And lastly, we're excited about the tech stack. It might not be the most glamorous thing, but we're super excited because it really does enable us to develop faster across all platforms. And we're really excited for what that means for us in the coming years. So let's dive into the details of the remodel. So on web, like I mentioned, we've evolved the interface to be more productivity-oriented. So for example, you can see there's a top bar now that really pulls to the surface a lot of the most important tools and features that you need to search, create, and collaborate. We've also worked to really reduce the number of clicks it takes for you to get your core tasks done, like adding data, editing that data, flying to destinations, and more. And like I said, this new UI is really our first step in hopefully better supporting your key workflows on web. Of course, if anyone's done a home remodel project, you know that there are many delays to the timeline. So last year, we tested out mobile content creation, but this year, we are finally very excited to say you can now add map, or you can do map making on iOS and Android. And so this creation on your mobile device means that you can directly add on iOS and Android. You can use your device's camera to add these photos to your features. You can find and save your location with just a few taps. And we've worked to improve the architecture so that you can really easily navigate between search, features in your product, Street View, and more. And last but not least, starting today, so hot off the presses, we have rolled out an initial integration with Delve to aid in sustainable urban development. So Delve, if you haven't heard of them, is a generative design tool for real estate developers and architects. And so using cloud computing to create and evaluate project feasibility, Delve is able to help users generate building designs and explore solar potential for different sites. And you're able to compare these different sites based on metrics or constraints that you're inputting. So quality of life constraints, sustainability goals, financial, regulatory, zoning constraints. You're able to compare all of these options within a matter of minutes. So if you want to learn more, or if you want to sign up for the preview yourself, visit this medium length link of google.com/earth/about/delve. All right, and with that, I will hand it back to Patrick.
Thank you, Chi. So if you want to try out Earth today, you can go to earth.google.com or scan this QR code to try out the mobile versions. And if you want to learn more about Earth at Geo for Good, there is a lightning talk later today on climate change mitigation that covers some of the generative design capabilities Chi just mentioned. There's also a talk tomorrow, Google Earth Web and Mobile Essentials for Land Managers at 2:30. So we hope to see you there, and thank you so much. Now I'm going to hand it over to Alicia and Steve to talk about Earth Engine.
Hi, everybody. I'm Steve Greenberg. I lead developer relations for Earth Engine.
And I'm Alicia, product manager on Earth Engine. We wanted to start today with talking about Earth Engine's mission statement, which is to build the leading geospatial analysis platform to advance planetary sustainability and resilience to climate change. We're the tool for you, the geospatial community, to solve the major challenges facing us with climate change and sustainability. In this talk, we aim to help you understand how Earth Engine has been making impact since we last met and the big areas of investment, and introduce some new features. In addition to what Rebecca has already highlighted, we'd like to start with some of the impact that the Earth Engine has had in the last year across this community. Let's take a look first at the non-commercial and research that continues to inspire us year after year. Many of you will have heard about Map Biomas, that built a land cover change detection platform in partnership with numerous organizations in Brazil. As you can see, they've had incredible impact in the Brazilian territory through science and making knowledge about land use accessible to conservation and combating climate change. Now, Map Biomas is teaming up with Indonesian experts and local civil society organizations to scale the platform to Indonesia, a region that has seen 233% forest plantation growth since 2000 to 2019. Recently, the Map Biomas Indonesian team presented their work to 3 government agencies in Indonesia and is optimistic about the impact that Map Biomas will have in monitoring land change in that region. I want to turn to water management next. OpenET helps water managers across US Western states make decisions about water use, basing their decision on historical data and near real-time satellite evapotranspiration, or ET data. Powered by Earth Engine, OpenET combines over 7 different ET algorithms into an ensemble algorithm to put the best science possible in the hands of decision makers. Just last week, OpenET launched a new API powered by Earth Engine, making it now possible for developers to integrate OpenET into their own systems. Now local communities and water agencies across the West are taking up and using historical and near real-time data from OpenET. The Map of Life, developed by the Yale Center for Biodiversity and Global Change, is one of our earliest partners and users of Google Earth Engine, and is built on a full-stack Google Cloud Platform environment. We know that biodiversity is critical to the fight against climate change, as are the metrics to track it. In December of 2022, the Map of Life species indicators were formally adopted by the UN Convention on Biological Diversity, the 30 by 30 target known as Nature's Paris Agreement. So big congratulations to the Map of Life team on that. It's okay, you can clap if you want. All right. So back in June of 2022, we announced that Earth Engine was available for commercial and government use. And if you remember from last year's Geo for Good, we introduced a cycle of impact to sustainably manage the world's resources that included these government and commercial decision makers. So to follow up this year, I want to highlight some of the great work that's been being done by our commercial and government partners. Starting with Regrow, which is focused on accelerating the transition to sustainable food and fiber production, they use Earth Engine to expand their impact across the globe, enabling their reach to cover 1.2 billion acres of land globally. They've had impact working with household brands like General Mills, which is tracking regenerative agriculture across 175 million acres of land and finding opportunities to implement climate-smart farming across their supply sheds. Home solar energy is a critical component to SDG 7, the Sustainable Development Goal focused on universal energy access by 2030. But it's often unclear which households have the need and capacity to adopt solutions from commercial partners. Atlas AI, a Google Cloud partner, leverages Google Earth Engine to research, develop, and implement unprecedented hyperlocal socioeconomic prediction models. With those models and through their Aperture platform, Atlas AI helps companies like NG Energy Access that want to identify the optimal regions in Kenya for expansion, helping customers get access to affordable and reliable solar energy. The Louis Dreyfus Company has committed to eliminating deforestation and native vegetation conversion for agricultural purposes from its supply chain by 2025. Google Earth Engine has allowed LDC to leverage big data and advanced machine learning algorithms to monitor its supply chains as a basis to encourage farmers to adopt more sustainable agricultural practices and evaluate the environmental impact of their sourcing decisions. And in Brazil's Cerrado biome, which represents the highest soy-driven deforestation risk, LDC has achieved 100% traceability to the farm level and is deforestation-free for the 2 municipalities it operates in. Now I want to switch to the government and public sector. The US Census Bureau its mission is to serve the nation's leading provider of quality data about its people and economy. They need to maintain their geospatial database of a constantly growing nation and make sure new areas of growth are being accounted for. Google Earth Engine is automating a previously manual process that was used for the 2020 census that cost millions of dollars and required 120 staff spending 4 years scanning between 2 different vintages of imagery looking for growth. Now the US Census Bureau is planning to use the output from Google Earth Engine to update their master address file, ensuring that people are counted in the right place and allowing them to focus their resources on the harder to count places. The South Florida Water District manages water resources for over 9 million people. That means monitoring water quality with a big focus on the recurrent hazardous algal blooms in Lake Okeechobee. In partnership with Google Public Sector, South Florida Water District is leveraging Google Earth Engine for its readily available satellite imagery and Google Cloud to access terabytes of historical hydrological and water quality data. As a result, South Florida Water District reduced the time spent on data manipulation and gathering, allowing them to get insights faster, building predictions of harmful algae blooms, and improving the health of the water resource they manage. As you can see, there is impressive and important impact happening across our entire user base. But now I'd like to turn to some exciting launches and additions to the Earth Engine ecosystem. So we know that you need access to data to drive more sustainability impact. So we've been hard at work continuing to add the data sets that you need. And since the last time we met at Geo for Good, we've added over 100 data sets, including a top request, NASA's Harmonized Landsat and Sentinel-2 data set that creates a seamless surface reflection record for the globe. And as Rebecca mentioned, we're also launching Cloud Score Plus. I just wanted to highlight this again because this is a very important addition to the data catalog. And the best part is it's going to be in the image collection will be in the data catalog today. So check it out, hopefully, and give us feedback about it as well. So you know that Earth Engine is the place to find data. However, our small but mighty data team can't process every data set that you need. And we know that you, the community, has access to important data sets, and we want to enable you to share that data. So we are thrilled to announce the preview of Earth Engine Publisher and Community Data Catalogs. The new Publisher and Community Data Catalogs will live alongside the Google managed data sets in the Earth Engine Data Catalog, and will allow users to explore and access data sets from both data publishers and our passionate Earth Engine community. And these are enabled by collaborating with trusted partner organizations. So for preview, we'll be partnering with NGIS, as well as the awesome GEE Community Catalog to make this initial set of data available. All right, now I'm going to hand it over to Steve to talk about improvements in Earth Engine's analytical capabilities.
Awesome. Thanks, Alicia. So Earth Engine was launched over 10 years ago to address the sustainability challenges of the time. And I don't have to tell you that those challenges have only gotten more significant since. Now, Earth observation plays this critical role, and the tools, the ecosystem of tools that have been grown to use Earth observation data to tackle sustainability challenges has grown quite a bit. Earth Engine needs to integrate with all those tools. And so the team has spent the last year doing a lot of this work to build connections and integrations with the rest of the Earth observation ecosystem. And I'm going to tell you about 6 integrations that we are excited to talk about today. So we're going to start by talking about BigQuery. BigQuery is Google Cloud Platform's petabyte-scale analytical database. And by joining BigQuery with Earth Engine, you can accomplish things that you can't do on any other cloud. Because BigQuery is really optimized for large tabular data sets, and Earth Engine is optimized around really large image raster data sets. So we built a simple API to export tables from Earth Engine to BigQuery, and the results have been significant. For example, SEMA, a startup, worked with Woza, they're a Google Cloud partner, to create an agriculture solution. So it allows companies that are sourcing from the global supply chain to monitor the impact of their sustainability decisions, the productivity of their fields. And that's because key information is brought out of Earth Engine and into the enterprise line of business systems that folks who work in the global supply chain are used to working with. So this new connector that we're announcing is our first step of integration between BigQuery and Earth Engine, but you can expect much more. I also want to point out that BigQuery has a generous free tier, so for folks who are in the nonprofit and research sectors, you can get started with it for free. Next up is Python. So we hear from many of you a desire to do more of your Earth Engine work with Python, because Python is the most commonly used language for data analytics and machine learning. And that's because over the last decade and a half, the Python community has built a set of standards and tools that are really great for working with data. Initially, that was sort of tabular data with scikit-learn and pandas, but it's grown. And increasingly, initially, there was an expansion into unstructured data like audio and large volumes of text and images with deep learning models like PyTorch and TensorFlow, and data standards like Xarray that do a great job of handling multidimensional data. But more recently, we're seeing the expansion into geospatial workloads. COGS, cloud-optimized geotiffs, are a great file format for handling large remote sensing data on the cloud. GeoPandas extends pandas with geospatial functions. And most recently, GEE Map brings an interactive map into your Colab or Jupyter experience. And the bottom line is that we want all of you to be able to take advantage of these tools without leaving Earth Engine. Because already over 30% of Earth Engine users work in Python. And that's even though the JavaScript code editor is, without a doubt, right now, a better experience for doing geospatial workloads. It has 10 years of investment in it, and it is an optimized experience for analyzing Earth observation data. Earth observation is an inherently visual experience. You need to be able to pan and zoom the map to explore the world, to click on a pixel and see the band values underneath it, to draw polygons on the map and be able to roll up zonal statistics. So building this kind of customized experience is really important. And we're investing deeply in this. And we want to do it in a way that brings the best of the code editor to Python in a Pythonic way. And so today, we're announcing a partnership with GEEmap. So GEEmap is a Python module which delivers many of the code editor experiences that you like in a Colab or Jupyter experience. It was created by Dr. Qisheng Wu, one of our Google developer experts, and it was created in April of 2020. And since then, GEEmap has racked up almost 3,000 GitHub stars, and there are over 1,200 projects on GitHub that use it. So going forward, the Earth Engine team is co-developing GEEmap with Qisheng. We're featuring it in our documentation, and we're adding tests so that every time Earth Engine is automatically tested as it moves forward, GEEmap is tested as well. And that we're starting with a subset of functionality that we call GEEmap Core that includes some of the most critical experiences for working with Earth observation data. Folks working in Python often want to be able to selectively extract data and get it into a Jupyter notebook for doing work. You might want to explore the data. For instance, this is work I was doing just 2 weeks ago, taking infrastructure in Pennsylvania, and I wanted to do some quick clustering on it, quick and dirty. So I pulled the data out of Earth Engine into a Jupyter notebook, ran it through scikit-learn's clustering algorithm, and I visualized the results using matplotlib. You might want to do some similar extractions if you want to extract data for a deep learning model, or you want to run data through a hydrology model. And you've always been able to use Earth Engine export jobs to do this, and let Earth Engine do the heavy lifting. But sometimes you might run into scaling limits, or you might already be using a framework like Beam or Spark or Dask and want to use that for your data. And if that's you, then you should check out our new data extraction APIs. GetPixels and ComputePixels allow you to get data out of Earth Engine and into an environment of your choice. You can select your region of interest, your visualization parameters, your target file format, just like you can inside of Earth Engine. And workflows that are implemented with GetPixels and ComputePixels can be scaled with Beam or Dask or Spark and on Dataflow and Dataproc, which are cloud versions of those systems. We're also improving these data extraction methods to make it more easy to work with Python tools that you care about. So you can take images out of Earth Engine and get them into NumPy arrays. And you can take feature collections out of Earth Engine and get them into pandas data frames or GeoPandas Geo data frames. Finally, today we're announcing an Earth Engine integration with Xarray that we call XEE. If you haven't worked with Xarray before, it's a very popular Python package for working with multi-dimensional data. It integrates closely with Dask, so you can parallelize your Xarray workloads across multiple machines. And with XEE, you can operate on Earth Engine data just the same way you operate on arrays in Xarray. Xarray does lazy evaluation, so it only pulls down the data that you need, and it connects with a lot of other systems. And this connection is, we think, really exciting. So for instance, Xarray is a new file format, relatively new, that's becoming increasingly popular with folks doing climate and weather work. So if you want to get your Earth Engine data into the Xarray file format, Xarray and XEE can be a good middleman in that operation. Once you have data outside of Earth Engine, you might want to use it in a deep learning model, and this is our next announcement today. So this is one example. So Nick Clinton from our team pulled down some research from a group at the University of Copenhagen. And it's a deep learning network that counts trees. This is a picture of it counting trees in the code editor in Earth Engine. And what Nick did here is he took the model that was published by the folks at Copenhagen, hosted it on Vertex AI, and drove predictions through Earth Engine's code editor. Or let's say you want to classify crops. You might find the best results come from a deep neural network. Deep learning in Google Cloud Platform happens in Vertex AI. It was launched in the summer of 2021. Vertex AI now integrates with Earth Engine. So you can host your models in Vertex and get predictions through Earth Engine. Vertex has a lot of advantages over the previous Cloud AI platform. For instance, the size of a prediction image that you can drive is 10x larger than what it was in Cloud AI platform. Vertex is also extensible, so the team is hard at work right now on PyTorch integration and AutoML tables integration. Finally, Erdos Imagine. It's a very popular remote sensing software package, and we were excited to partner with Brad Skelton from Hexagon to launch LiveLink for Earth Engine this year. So LiveLink allows you to take your Earth Engine catalog data and combine it with local data from your organization. You can get the best of both worlds, Earth Engine's data catalog and back-end distributed computing environment, together with your local data and the interactive experience you're used to on your desktop. Alicia and I want to finish by acknowledging the most important thing about Earth Engine, you, the community. The Earth Engine community is astonishing. Together, you worked to build this book. It's been published by Springer Open, and it's available free for download. There are 55 chapters with 100 authors, 1,200 pages, and numerous tutorials and code samples. The authors maintain up-to-date copy on ifabook.org, and they're producing video walkthroughs of every chapter. And I want to acknowledge our Google developer expert community. So this is yes, actually, a lot of these folks are here, so we should applaud. Our Google developer experts are not only expert users of Earth Engine, they also give back. They share their knowledge of the community through blog posts and presentations and thoughtful answers to community posts. Qualifying to be a Google developer expert is a very rigorous process. They go through a portfolio review, a peer interview with an existing expert, and interviews with members of the team. And we've grown the program substantially this year. We started the year with 22 Earth Engine GDs, and we've almost doubled in size to 38 at this point. Many of these folks are actually here this week, so if you see one, I suggest you say hi. I joined the team 18 months ago. And I feel incredibly lucky to be part of this team, to get to work on these problems, to get to work with these team members, and to be part of this community. I know we have a ton of amazing Earth Engine content for you this week. So please enjoy the time. Please also come to Alicia and I if you see us in the halls and give us feedback. Tell us what you're using Earth Engine for. Tell us what you like. And with that, we're going to hand it over to Lisa and Yvonne, who are going to talk about the environment APIs.
Hi, it's great to see everybody. I'm Lisa, and I lead go-to-market for our sustainability efforts in Google Maps platform.
Hi, also from my side. I'm Yvonne. I'm a research scientist in Geo, and I lead some of the efforts on model development and data quality behind our new environmental APIs. And we are super thrilled today to tell you more about these new environmental APIs we just recently launched.
As you know, Google has made deep investments over nearly 2 decades in geospatial technology. We've been applying AI for years to some of the most significant information challenges facing humanity to empower individuals, organizations, and governments with quality information that will drive positive impact for our planet. More than ever before, now is the time when it makes sense for businesses to offer solutions to consumers that can inform and enable sustainable choices. Enter Google Maps platform. It provides information for developers based on the most up-to-date data that's accurate and constantly evolving understanding of the real world. It enables organizations to create amazing geospatial experiences for their users based on trusted information from Google Maps and the most comprehensive and up-to-date map of the world. And with that, we're thrilled to share the recent launch of our new environment category of APIs on Google Maps platform. We're hoping to make this platform the leading destination for developers to access unique and hyperlocal sustainability and climate data and insights. The environment category consists of 3 new APIs: air quality, pollen, and solar. These products apply AI and machine learning to environment data to give developers helpful information that can inform consumers' daily behavior and purchasing decisions and help reduce the time and cost of operating a business. I'll hand it off to my colleague Yvonne, who will share more about the impact potential of this data and deep dive on the air quality API.
Thank you, Lisa. We believe there is tons of opportunities for research using these environmental APIs. Just as an example, we have been leading a Horizon 2020 project recently with several research institutes from all around the world. But there's so much more. Let's just name a few examples. In the health sector, we're thinking of long-term health effects, respiratory diseases, allergies, and so on. There are several folks here, I think, working on environmental justice, where we know that air quality plays a big factor. We have partners working on economics and behavior change and also productivity. And there's so much to look into. I'm very curious what you guys are working on and learn more about it and see how our environmental APIs may help your work. With that, let's look a bit deeper into the air quality environmental API. Bit of background, currently about 40 million Americans are suffering from COPD and asthma, two conditions that are heavily impacted and often exacerbated by air quality or pollen. The WHO, the World Health Organization, names air pollution as among the biggest environmental health risks globally, and a recent study by Harvard just showed that almost 9 million preliminary deaths are linked to air pollution. And a recent estimate of the World Bank estimates the global costs of air pollution to about $8 trillion every year. With these numbers in mind, let me say it with Christiana Figueroa's words. When 99% of the global population breathe unhealthy air, the time is now to provide meaningful information for healthier decision-making and resilience. But why is it so difficult to provide meaningful information? Well, it starts with the sources of air pollution. Many people often mistakenly think that they're only affected by air pollution when they have a local source close to them, such as a wildfire or traffic below their house. However, air pollution can also originate from faraway sources, such as desert dust, being transported often all around the world. These various sources, together with the complexity of physical and chemical processes in the atmosphere, make air pollution highly dynamic. This time-lapse video shows air pollution changing in the Bay Area, where green represents here good air quality, and yellow and then red presents bad air quality, which is harmful to everyone. You see how dynamic it is and how it changes in space and time. This is a big part of why it is so challenging to map air pollution at a specific location with classical methods. Among those challenges, just to name a few, are delays in reporting of sensors or the simple lack of sensors in certain areas. What we do to resolve this challenge is to fuse information from various data sources, combining amongst 50,000 governmental sensors worldwide, together with traffic data, with satellite data, with atmospheric chemistry models, with low-cost sensors and weather data, and wildfire information. We use machine learning processes and also physical modeling to do this combination of the various layers to get the best out of every data source. And this unique approach enables us to provide information also when one or several sources are not available. All in all, we are calculating air pollutant concentrations on a 500-meter grid level in more than 100 countries every hour. We also calculate about 70 local air quality indices and provide those all around the world. We also continuously monitor our accuracy using the leave one out cross-calibration methodology, which basically means we take one of those 50,000 governmental sensors out of the model, run the model, calculate what should be the pollution at that specific location, and then compare it with the measurements that we took out. We do that for each and every one of those 50,000 sensors every hour. I think that's quite impressive. There are 2 dedicated sessions to walk you a bit through how to use the air quality APIs and the other environmental APIs. But just as a background, We're providing in our air quality API current conditions every 1 hour, pollutant types and concentrations, and the local air quality indices. We have a 30-day history, and we provide the data also on a heat map. And a last word about who is currently already using our data. There is a variety of industry that can benefit from air quality and the Pollen APIs, such as the smart home, healthcare, mobility, travel, real estate, insurance, and many more. And with that, I hand it back to Lisa to walk you through the solar API.
Thanks, Yvonne. So the opportunity for solar is brighter than ever. Residential and commercial solar systems account for almost half of the expected growth of renewable energy in 2023. And in 2024, the International Energy Agency projects a possible 150 gigawatts of new distributed solar generation will be installed. That's potentially tens of millions of PV systems. The Solar API uses high-quality imagery and maps data with AI models to analyze imagery to understand the details about individual roofs, including slope, obstructions, and shade patterns. Then we add in weather data to get accurate information about the amount of sun hitting a roof. First, our API returns raw solar information for an area surrounding a location, such as the image of a rooftop, a digital surface model for pitch and elevation, plus shade and sunniness layers. Second, we distill this raw information into insights about the building and solar potential, including the size and dimensions of the roof and key solar installation details. We built the Solar API from what we learned from our consumer-facing Project Sunroof tool that has helped countless homeowners understand if solar is a good option for their house. In collaboration with industry partners over the last few years, we designed the API to support commercial use cases to help accelerate efficient rooftop solar installation without ever having to visit a site. But we see endless opportunities for additional applications of this data in the policy and research spaces, as well as across a variety of other industries such as utilities, finance, and property developers. The API is available currently in 40 countries, covering over 320 million buildings, with consistency across markets worldwide. We're not done, though. We know there's new buildings coming online every moment, and the interest in distributed solar is not limited just to the countries we currently cover. So how can you get access to the Google Maps platform environment APIs? You can access the environment APIs at mapsplatform.google.com. There's a $200 per month usage credit, which covers thousands of API requests for each of these APIs each month. Additionally, Google Maps Platform offers public programs that support the work of nonprofits, startups, faculty, and crisis response.
Lisa and I would like to thank you so much for engaging with our new environmental APIs on Google Maps Platform. And with that, back to you, Raleigh.